All right, so we're going to begin today with Unit 6, Lesson 1. And I believe we've already started this activity, but I decided I would start with problem 2. That way, if somebody was absent, they would at least get the information that we... So we're going to be completing Unit 6, Lesson 1. So if you don't have a copy, please get a copy from your teacher. We started the activity a couple classes ago, and so I'm going to pick up with problem number 2. That way, if a student was absent, they're able to at least listen to all of the information. So this problem, it says, suppose a windmill has a radius of 1 and the center is located at 0, 0. Write a function describing the relationship between the height of the windmill and the angle of rotation. Explain your reasoning. So turn the video off, write your answer to that question, explain your reasoning. If you finish that, go ahead and move on to problem 3, which is basically a continuation of problem 2. This time they're going to be changing the length of the windmill to different lengths and then asking you to describe the equation or just describe how the function is changing as a result of changing the length of the blade. All right, so this problem here, when we did the problem for this function called y equals, we have 3 numbers. It is a sine function. So for the angle measurement, again, we're using some angle rotation of theta, so we don't know what that is. The radius is 1, so that number goes here. And then there's the height from the ground, and that information is not being provided here. So based on just the windmill itself, this would be the equation for this problem. So the 1 represents the radius, and then we're doing sine because we're talking about y value or height. And again, we're not including the first number because we don't necessarily know the height the windmill is from here to the ground. So we're going to assume that this point here is actually at 0, 0, and the length here is 1. So in problem 3, we're going to change the length of the blade. So if you write the equations for each of those, turn the video back on when you are finished. So again, we don't know the height, so all we're going to have here is the multiplication problem part of the equation. And we discussed this in the last, unit 4. So the angle measurement is going to still say theta because, again, we don't know the angle of rotation. And what's going to change here is the radius of the blade. So for the first one, it's going to be 3 times the sine of theta. So whatever sine of theta is on the original unit circle, all the x's and y's will now be, in this case y, will now be 3 times longer than it was on the unit circle. This one here will be 0.5 times the sine of theta, 7 times the sine of theta, and 2.8 times the sine of theta. So what we're going to begin in this lesson is actually establishing not only the equation, again without the height, or without the how far is above the ground, and what the numbers that we're multiplying to the sine is, how is that actually changing the graph. So in this problem here, they're asking you to match the graph with each equation. So when you're finished, what you believe is the right answer, please turn the video back on. So I'm going to start with C. So problem C, I know that the sine of 0 degrees is 0. I know that the sine of pi over 2 is 1. Sine of pi is 0. 3 pi over 2 is negative 1, and we're back to 0, 2 pi. So the graph, the blue graph here, this is the sine function with no alternatives to it. So it matches up with our unit circle. So when I multiply the the original sine function or the unit circle graph for the sine function by half, it means all of the answers will be half as high or half as much as they were originally. So that means I'm still, so at 0 I'm still going to have an answer of 0. But at pi over 2, where the answer was originally 1, it's now half. And also, when we're talking about 3 pi over 2, the answer was negative 1. Well, now it's going to be negative half because it's going to be half as much. So the yellow graph is A. And then the third graph, again using the same reasoning, so 0 is going to still be 0. At pi over 2, the sine function is 1. So when I multiply the sine answer by 3, instead of the answer being 1, it's not going to be 3. At 3 pi over 2, it's going to be a negative 1 for the original function, or the one on the unit circle. So that means for 3 times the sine, the answer negative 1 now becomes negative 3. So this last graph here is graph B. So keep in mind that the number you're multiplying the sine function by, which again are the answers on the unit circle, that's going to be how the answers are going to change. So if I would have had sine equals, let's say, 5 times the sine of theta, that means that particular equation, instead of us being at 1, that means the answer is going to be up here at 5, because it's going to be 5 times greater than it was on the unit circle. Same thing going the other direction. The answer to this graph will be down here at negative 5. The answer at 0 will not change. It'll still stay the same. So when you have 5 times sine theta, the graph will look something like this. So what we're talking about here is what we call the amplitude. It's the maximum distance between of the values of a periodic function above or below a midline. So a midline is basically a line that divides the graph in half. So it's kind of like a line of symmetry. So the graph below it and the graph above it are the same shape. Usually, you think about taking this and then rotating it around this point. This graph, this in red will match up with this one, for example. So that midline basically splits the graph in half. And then the amplitude is the distance from the midline to the top or the bottom. And it is a distance, so that means that number is going to be positive. So this problem here, they're showing here, so this graph here, the amplitude is 2, because from the midline up to the top of the graph or to the bottom of the graph, that distance remains 2 throughout the entire graph. So in this problem here, we're asking to determine the amplitude. So I would suggest, first of all, draw the midline, and then determine how much the graph goes up or down from the midline. And then turn the video back on when you're ready to go through either the first 2 problems or all 4 of them. All right, so in the first problem, 4 is the top, and 2 is the bottom, so halfway between 4 and 2 is 3. So midline, this problem is 3, or y equals 3. I'm going to write the equation for it. That's the midline. And the amplitude is how much you are above the midline or below the midline, and that's the amplitude. So in this problem here, the amplitude is 1. The second problem, the top is 4 and the bottom is 0. So halfway between 4 and 0 is 2. So this would be the midline. If you want another way of doing that, then take the number at the top, take the number at the bottom, add the 2 together and divide that by 2, and get the average of those 2 numbers. And the average of those 2 numbers is where the midline is going to be. So the amplitude from the midline up is 2, from the midline down is also 2, so the amplitude in the second problem is 2. If you've not done the other 2, turn the video off and continue working on the last 2, and then turn the video back on when you're ready to continue.
Alright, so the top is at 4, the bottom's at -4. We use the averaging rule here. So if I take 4 plus -4 and divide that by 2, that means the midline will be at 0. And then going up from the midline is 4, and going down from the midline is also 4. So the amplitude here is 4. And then the last one, the top of the graph is at 5, the bottom of the graph is at -1. So I take 5 plus -1, and to take that answer and divide it by 2, that's going to be 4 divided by 2, which is 2. So the midline for this one will be at 2. And then the amplitude would be how much you go up from there, which is 3, and how much you go down from there, which is also 3. So the amplitude here is 3. Alright, so it says complete each problem using the same windmill from problem 2. So let's say that the windmill blade has a length of 1 and is 6 meters above the ground now. Write a function between the relationship between the height of W in meters and the angle of rotation. And then you can do the same thing for problem B, write that equation. When you go back to Canvas and go under modules, look for the decimal sketch called unit 6 lesson 1, click on it, and you will see the equations for 6A and for 6B. And then from that, just click on each circle to show the graphs. In other words, you're going to be checking your answers to see if you actually wrote the equations correctly, as well as see how the graphs are impacted based on those equations. So that's what they're asking for here in E. How does the graph in 6A compare to y equals sine of theta? So what in this problem, how did it change it? Same thing with B, the same question. How does problem B, based on what the equation you came up with, how does that graph change from the y equals sine of theta, which is the sine graph for the unit circle? And then it says complete the remaining problems in the decimal activity. So go ahead and go over to Canvas and open up the activity. Alright, so for the problem you guys completed, hopefully you got y equals sine of theta plus 6, 6 being the height. So when we were writing the equation before, we would do 6 plus and then the multiplication problem. So in this problem here, the addition problem is coming after. You may have written the addition problem first, and either way is okay. So in the first equation, describe what happens to the graph. So you'll notice the graph itself, hopefully you notice, move up 6 from where it was originally. And the second graph actually moves up 9. So that means where we were here at 1, at 3 pi over 2, now we're now up here at 7. The graph itself has moved up 6. And this one up here, there we go, and that one has moved up 9. So from negative root 3 pi over 2 to comma 1 now to negative 3 pi over 2 comma 10. Go ahead and head back to the original activity, ignore step G here, and move on to the next part. So a midline, again, as we defined earlier, is that distance is halfway between the maximum and the minimum. So keep that in mind as we're working through this. So in this problem here, if you would identify the midline and turn on your the computer or video when you're done. All right, so for this one here, again, we talked about doing that averaging. So I take 2 plus the negative 4, divide that by 2. Hopefully it shows the midline to be at negative 1. And when we write the midline, we write them as equations, like y equals. This one here, the top is at 1, the bottom's at negative 3. And we divide that by 2. And the midline is also, again, at negative 1. So, again, the equation is y equals negative 1. I'm going to stop at this video here, and please go to the next video, and we'll finish up this handout in the next video.